I'm Diana Meshcherikova. I'm Associate Professor and Docent at the Medical University of Vienna, the head of the research group Molecular Systems Biology and Pathophysiology at the Institute of Pathophysiology and Allergy Research, Center of Pathophysiology, Infectiology and Immunology, and the head of Systems Medicine Subdivision at the Austrian Platform for Personalized Medicine. The research concept of my group is based on a holistic approach for deciphering the complexity of multifactorial diseases and deciphering the pathomechanisms of diseases. And it can be best described by the aphorism of philosopher Aristotle: the whole is more than the sum of its parts. Deciphering the disease complexity indeed demands implementation of holistic approach, which covers the level of biological hierarchy from individual molecule to gene networks to pathways and pathomechanisms, and then to clinical relevance. So my long-term research goal is to expand the knowledge on cellular checkpoints which redirect the physiologically balanced systems towards the pathophysiological situation, leading to development and progression multifactorial diseases such as aberrant immunity, chronic inflammation, and cancer. So we developed and successfully applied the systems biology-based integrative algorithm named by us as MUSICO, abbreviated from multi-gene signature to patient-oriented clinical outcome. And the MUSICO is based on implementation of consecutive analytical modules, integrating advanced gene expression profiling, prognostic predictive modeling for clinical outcome, then digital pathology and systems biology, including the integrative analysis of transcriptomic datasets. MUSICO, what we believe, thereby bridges systems biology and systems medicine to maximize the benefit of the patient. Regarding the applied biosystem technological solutions, in terms of scientific curiosity, for me it is also a great advantage that one can already during the run, in the real time, look how the genes behave. So look for the gene expression or up or down regulation upon perturbation conditions. And I would say that for me, the real-time PCR machine is also a test system for the real scientific interest of a scientist. To be a scientist is not a profession, is not a job. This is a calling, a mission, a gift. To see the shiny eyes of young researchers after very first successful experiment, so very first successful results, first own conclusions, first own proven hypothesis, is one of the best things for me about being a scientist. And I am also very proud that among such extraordinary next generation scientists is also my daughter Anastasia, who is a postdoc at the Medical University of Vienna.
My name is Anastasia Meshcherikova and I am a postdoc at the Medical University of Vienna. I'm working in the field of immuno-oncology and applying various integrative systems biology-based approaches for deciphering the complexity of multifactorial diseases, also dealing with compendium-wide analysis and multiple special softwares and tools for a comprehensive research analysis. So in my research focusing on lymphoid structures and also on sphingolipid networks, some important questions are low-expressing genes and also closely related family members of the same gene family. And for those, high-throughput gene expression profiling with high precision and high sensitivity is very important, and also special tool for the follow-up analysis. Here, for example, important for me is the Gene Investigator platform, which enables a very specific compendium integrative analysis of your data and the comparison of what is very interesting of your data with other publicly available data sets to dissect novel disease mechanisms and novel regulatory gene networks. Applied biosystem technologies are an important tool in my research as I'm working with multi-gene signatures, with self-created multi-gene signatures, and applying them from profiling of patient material and also for in vitro cell-based models. And here, the multi-gene signatures consist of about 40 or 50 genes, and it's important, for example, that you have the 384 well plate, where you can, in one experiment, gain a lot of data of different genes, of different samples, and in one run have already a very great scientific answer to your first scientific question. So my outlook is that the technological solutions help a lot to give the step from systems biology to system medicine, and more specifically to personalized medicine, which is, I think, the final goal of the newest research, to have the specific biomarkers, the specific therapy for the patient. So for me, the best thing being a scientist is the great possibility to have the possibility to help a patient. So I think a great job is being a doctor, but not everybody can be a doctor. But as a scientist, okay, it might take longer, you need longer research, more steps, you work together with others. But finally, I like to work in translational research in a university hospital to have the possibility to help the patient at the end with my research, what I'm doing.